Okay, what I've done here, I've finished up here. This is example 7, and we have just x plus 2 quantity squared. We want to know how it transforms, okay? And we want to graph the parent function, and then we want to graph this one over top of it. So the parent function, which is just x squared, I figure we need to write down what the axis is of this. So it's not, there's nothing there. There's nothing, there's nothing. In other words, all you have is this. So there's no plus or minus there. There's no plus or minus here. So x equals 0, and the vertex is at 0, 0. So that means if we were to graph this, I put in some points. So I tried to find out what was f of 1, f of 2, f of 3, and f of 4. I just plug that in. So 1 squared gives me then 1, 1, because 1 squared is 1. When I plug in this for x, so x is 2, what I get back is y. 2 times 2 is 4. I plugged in this for x for the next one. So x is 3. So when x is 3, what do I get back? 3 times 3 is 9. Then I figured I'd do f of 4. So when I plug in x is 4, I get back 4 times 4 is 16. And I figured that would be enough for us to graph our parent function. And then we want to look how this transforms, okay? So that's the main thing we're after, just how this thing transforms, okay? So what we can do here is let's see if we can graph our parent function. All right, and we're going to do this with just a dashed line so we can keep one straight from the other. All right, so I have a 0, 0, and I've got 1, 2, 3, 4, and up looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be enough. All right, so 0, 0, then I have a dot at 1, 1. Then I have another dot adjacent to that, because my axis of symmetry comes right through here. 2, 4 is another dot. 1, 2, 1, 2, 3, 4. So about there. About here. And 3, 9, 1, 2, 3. And 9 was up here. So that's my parent function. We decided we would do that with just a dashed line. Okay, so now we want to see how this would change that. All right. So what's the vertex? And well, what's axis of symmetry for this? X equals what? A negative 2, right? So what's my vertex then? Be a negative 2, comma, there's nothing here, so 0. So go to negative 2, 0. Now, how would this graph change? It'd be just like this one, because A is this is 1, and so it would go just like this. So what did it do to our parent function? That's what we want to know. So what was the transformation? Did it go up, down, left, or right? Remember what that does. That changes the vertex. So transformation is left 2. So that would be our answer. It moved it left 2. Okay, after looking at the homework, I realized I can teach this to you in a really super fast way. I don't think it's necessary for you to go through all the making the table if you understand what's going on here. Okay, now this is our vertex. Remember our vertex? By the way, stop and write all this down. Okay, this is our vertex. And it's at opposite H, and K. So it actually gives us an X and a Y value if we know how to read it. Okay, so we want to see how it transfers, or to the transformation from our parent function. All we're talking about is the vertex and the shape. Okay, so what would this graph look like? All right, now would it be right side up or upside down? That right there is a positive x squared. It's going to be right side up, and it's 1, so it's going to look like a parent function. So it's going to look like a parent function like this, approximately. But what's that 5 going to do? It's going to move it up 1, 2, 3, 4, 5 units. So our graph should look like this, and this is all you need. And the transformation was what? It's moved the vertex up 5 units. So up 5. Okay, take a look at this one here and see if you can figure out how it's going to move. What would a sketch of the graph look like? It's okay to be wrong, but please try. All right, so this is positive, so it's going to be right side up. Okay, so now it's going to look like this. That hasn't changed any, so it's going to be right side up. But where's that vertex going to be? Well, that vertex right there is going to be at -1, 6. So that vertex, excuse me, -1, -6. So -1, -6. Oh, by the way, I forgot. On number 7, I forgot to put the y equals in front of that, and I thought that might bother some of you. And it should be there. That was my mistake. All right, so back to this one. This is how I like to do them. I think, okay, that's moving it down 6. So I don't like to start like this. I like to start down 6. 1, 2, 3, 4, 5, 6. And then to the left 1. So my graph should look like this. And that's all you need. Oh, what was the transformation? I forgot to put that. So that's one thing we want, trans. So that was down 6. And left 1. By the way, you could say left 1, down 6 first. It doesn't matter. Okay, let's take a look at this graph here. All right, what's that negative going to do? It's going to make it look that way, right? And that's a 1, so it's a regular parent function shape. All right, so what's that going to do? Where are things going to be at? Let's see my graph. See, that's up 1, to the right 4. 1, 2, 3, 4. Vertex is right there, but it's upside down, so it's going to go this way. And what's my transformation? That was right. 1, 2, 3, 4. So right 4. And up 1. So on the homework where it asks you to graph it, all you need to do, you can do a hand graph instead like this. Instead of using the paper, you can put it to the left or where it says transformations. You don't need to use the table. I'd like for you to be able to read from this and do a sketch of what the graph would look like. So this is my answer for 8. This is my answer for 9. And this is my answer for 10. Okay? So there's 8, 9, and 10. Hopefully this will be easier than I thought it was when I actually taught them. Like, yeah, this seems pretty easy. Oh, transformation. Also, it flipped. I forgot that. That's very important. Why did it flip it? Why is it upside down? Because of that negative right there. Okay, so go ahead and do your assignment. It'll be in the Google Drive where I showed you. And take a picture of your work and turn it in. And best of luck to you guys.